Hello, everybody. For the last 2 years, I gave a talk about the state of the etnaviv graphic stack, and I'm happy to continue doing so today. I will cover different topics today, from CI to Glass 3, and I will talk a little bit about some legacy love. But before we dive deep into the topic, let's talk briefly about me. I've been working on etnaviv for many years now, and in the early days I mostly was interested how a GPU works, what the components are used, and how the big picture looked like. For a long time it was just another hobby for me, and I did some small contractor work that I lovely called my etnaviv days. But visually, as you can see, the old color scheme from my old presentation has changed. It's not that black and white theme anymore, and that's for a reason. I started doing contractoring work for Igalia full-time for the past five months now, and I'm really happy to get the opportunity to work in the open source graphics stack. So, enough about me. For preparation for this talk, I basically looked at what happened in the different Git repositories. And let's start with the kernel driver. I think the last year was more or less in quite area of work in the kernel area. But the biggest feature that happened was the support for NPUs done by Tomeo. As the NPUs share a lot of similarities to normal Vivante GPUs regarding the DMA fetch engine and its command stream, it just needed a handful lines of code to support them. Also, all the reverse engineering tools we used for the GPUs are supported there. The other new big parts that happened in kernel land were the addition of new hardware database entries for new supported GPUs and NPUs. Such hardware database entry provides information about supported features and limits about a specific GPU, and that will be consumed by the user space. And overall, there were some small fixes, improvements in kernel land. On the Mesa side of things, a little bit more happened in the GPU stack. Lukas Dach from Pengotronics and I were working to fully support and enable MSAA. There are still some little problems, and that's why it's behind an opt-in feature flag. The same is for this tile buffer sharing thing Lukas is working on. There are still some problems, and it's also behind opt-in feature. The etnaviv Gallium driver supports or gain support for performance warnings. For instance, you will get such a warning if there's a shader variant that gets compiled during draw time, or if an application uses conditional rendering that is implemented onto CPU, as there is no hardware support for this feature. The last month, I was working on different compiler linker topics. For instance, we support negative inline immediates now. Our own near lowerings got better and helped to decrease the instruction count. And I finally was able to tackle an item that was sitting for too long on my to-do list. Piglig's GLSL routing tests are now passing, which is really great. With all the time I have now to work on etnaviv, I was also able to tackle some cleanups in the base of the Gallium driver. Example, by removing some hand-rolled conversion helpers, which is a nice step towards more cleanups that will be coming later. And also, we were able to fix a lot of crashes in CTS and also fixed a lot of fails. The next topic I will cover quite quickly is CI. I'm a very big supporter of unit testing and continuous integration, as it makes the life of the developer much easier and helps to prevent regressions. If I need to describe the etnaviv CI at the moment, I would say it has proven its value. It forced other developers to take care of etnaviv and don't break it. My board farm is still bare metal based, and it costs zero maintenance for me. It just runs. But to be fair, my board farm is still running in this manual mode where you need to explicit press a button in GitLab that your job, your merge request gets run on etnaviv CI. But I hope that this will change soon too. But the board farm is used in the nightly CI runs that are happening in Mesaland. My board farm currently consists of 12 devices ready for use. So they are fully connected and can be used right now. As you can see, I have mainly GPUs, different GPUs under test, and mainly GC 2000, 3000, 7000 based GPUs from, only a handful of these devices are registered as public runners. This has mainly two reasons. I wanted to do more work on the Gallium side than CI for the moment, and I waited for this CI-tron thing to happen so that I can evaluate it and hopefully can convert from bare metal to CI-tron in the next month. There's one thing that I'm really happy about is that the community wants to provide own board farms for CI testing. For instance, David wants to provide some Librem 5 dev boards. Sam wants to provide some GC880 based board farm. And also at Igalia's headquarters, there will be coming a board farm specific for etnaviv needs. So these are really, really exciting news, and I can't wait to see all the board farms hooked up in free desktop's GitLab CI infrastructure. And if you're interested in running your own board farm, just say hi to me and we can talk about it, because there are different more models supported by the etnaviv driver than just this handful provided here. So, my personal goal for the last 2 to 3 months was to get Class 3 working fully conformant on etnaviv on a GC7000L based GPU. I spent a lot of time reverse engineering, verifying new shader instructions that get used for the job, try to understand the differences between the different GPU models, and got really, really far. I have only some lowerings that I need to do for fragment shaders that are not yet fully done yet, but as it looks really, really nice. I'm able to support multiple render targets, 4 or 8, depending on the GPU model. The merge request for this is not yet done, as the Gallium drive at the moment is written only with one render target in mind, and it takes a little bit of refactoring to nicely integrate it to the multi-render target support. So everything looked fine, but then bigger near refactoring was happening, and it caused a lot of problems, and I had to shift my focus to looking more into this near refactoring thing than into Class 3 stuff. In theory, it should be quite easy to use the new legacy helpers, and the job should be done in 1 or 2 days. But sadly, the current backing compiler had a different opinion than me, and so I spent really some days to get it working. By working, I mean ShaderDB looks okayish, and CTS tests are okay too. But as you can see here, my first attempt wasn't that great. So I need to go back to the drawing board. I came up with a nice solution, but I had to clone existing render near paths that is not existing in the tree anymore. I did the whole source modifier thing now on my own, and it took me about a week to get to this point, and ShaderDB is now much better. So, but I got feedback from the community that the compiler backend isn't that nice, And the weakest point is really the current backend compiler. We do a lot of tricks. We do near constant value pollution, I call it. We misuse the upper 32 bits. And this has the side effect that near validation doesn't work. We have a lot of areas where we in blind flight mode late in the compiling process. So you need to add manually some near print shader calls to see really what is the last near shader you are seeing. And the current assembler is not aware of different instructions encodings. So you see a lot of funny source code like this where you need to set some texture bits and bytes to get, for instance, here the load instruction. And it feels and looks really strange to me. And the biggest pain point, we have miscompilations. I've been working on some shader-based emulations, and they are working on different GPUs, but not in etnaviv, because the compiler miscompiles it. And also I had to spend quite some time to work around how the compiler is written. There are near lowerings, not in a pass, but shared across the source code, which is really hard to work with. So I'm really proud to tell you that I've been working on a new backend compiler called the etnaviv backend compiler. There are quite some trends in compiler land right now, and I will be honest with you. Not a single line of Rust, no SSA-based register allocator because of the nature that the instruction set architecture is. I use a lot of EtherSpec magic to do the job. I use the old register allocator. And finally, we have a backend IR with own optimization passes. We are supporting control flow, different bit sizes. And as a test bed, I used OpenGL. But I'm a lazy guy. So I looked around in the tree, fell in love with Asai's compiler, basically copied everything over, renamed stuff, and added the needed VEC4 sugar on top of it. As I told you, I was using OpenGL support to test bed this based on the work collaborated. And so let's have a look at the really simple OpenGL shader. Nothing too fancy, a simple rotate. And here we can see the backend IR after copy propagation, that code elimination and liveness analysis. And it really looks lovely, what I say. And I even made it possible to annotate source registers, like here the base address or the offset, in EtherSpec. So in the XML file is really where everything is lying. And here we can see the final assembly, and it passes the Piglet test. All the EtherSpec changes needed for EBC are merged already, and EBC will come later this year. So now a quick talk about legacy love. The etnaviv GPU stack will bring new features to all the GPU models with the help of shader magic. The etnaviv supports many GPUs with different supported features, and the binary blob does some legacy tricks in the shader, and so does etnaviv. And the plan is to make more use of these shader emulations, for instance, to emulate logic ops and do own lowering specific to etnaviv, like border color lowering. From time to time, etnaviv feels a little bit dead, but I think that these times are now changing. And now it is time for some questions.
So you mentioned that you are looking into border color lowering. Is this meant to be conformant for GLES 3.1 border color in support, or is this just a good enough to be better off for the big GL, which wasn't conformant in the first place? And the reason I ask is that the obvious way to do border colors that's everybody's first attempt is not conformant as far as I know, and doing it conformant is very expensive and probably not worth it for the legacy hardware you had in mind. So.
Yeah, the initial goal is to get it running somehow. So conformance is not the main goal for this one. Okay, if there aren't any questions, I would say thank you.